Hi, this is G. Ramachandra, working as a assistant professor in Chalapati Institute of Engineering and Technology, LAM, Guntur. Today I am giving the lecture on data models. First of all, we have to be going to discuss about the definition of the data models. What is a data model? Data model define how the logical structure of a database is modeled. Okay, here we are mainly to be focusing on that how we can to be maintaining and based on which structure you have to be maintaining the data. So that can to be modeled by based on the any one of the data model. The next one is the data models are used to show how data is connected to each other and how they are processed and stored inside the system. So the mainly the data models can to be focused on that how that's the data is to be connected each other in the database system, and how that's the data can to be processed, and how that's the data can to be stored in the inside of the system, inside of the database system. Remember this point. Our main intention is to storing our data into the database by using of any one of these models. Okay. There are the many data models being used nowadays, but mainly we have to be using the relational model. That's the relational model is the most widely used model. At nowadays we have to be using this model. Okay. Yes, these are the different types of data models. These are the three types. The first one is object based models, second one is record based logical models, third one is physical data models. These are the three types of data models. Each and every type can be categorized. So then the object based logical models can to be categorized into the two types. Those are the one is entity relationship model, and then second one is object oriented model. Second type of data model is record based logical model. So that's the record based logical model can to be having that's the three types of models. The first one is the hierarchical model, network model, relational model, and then physical data models. So among all these data models, mainly we have to be focusing on that relational model only. Okay. Now we'll be discuss about the each and every model in detail. Yes. First one is that is the hierarchical data model. So this the hierarchical data model was the first DBMS model. So why we have to be using the DBMS? Already we are discussing that's the previous lectures. That's the database management system is a software that is used to storing our data into the database, or used to storing and managing the data into a database. Okay, but how, in which structure we have to be followed to storing our data into a database. Okay, so this is the first model has to be developed to store our data into the database. So this is the hierarchical model, that this database model organizes data into a tree like structure format. So how we can to be maintaining the data into the database in the tree like structure format only, with a what is a tree like structure, with a single root to which all other data is linked. Okay. The next point is that the hierarchy starts from the root data and expands like a tree, adding child nodes to the parent node. So already we have the some idea about the how that's the tree structure can to be have. So that's the tree can have that's the root node and their left child, right child. Okay, so that's the way we have to be construct, or that's the way we have to be organize the data into a database. In this model, a child node will only have a single parent node. Remember this point. In this the hierarchical model, must and should we have only one parent node and remaining all are the child nodes. We must and should be followed this the principle in this the hierarchical model. This model efficiently describes many real world relationships like index of books, receipts, etc. So for example, one department can have many courses, many professors, and of course many students also. So for example, here it is that see this one. How we can to be arranging that is, first what is the root node? Here it is that one department. Okay, that is the, for example, here we have to be taken a CSC department as a root node. So number of courses, okay, number of courses are to be coming under this the CSC department, and then many professors, So number of professors are to be including, and then of course many students also. So these all are to be coming under this the one department. So this we have to be arranging all these elements into the tree structured format. So this is an hierarchical model. Now we have to be see this. This is the one college. In our college can have that's the department is the one child and the infrastructure is the another child. Here there is the course, teachers, students. Okay. So each department can have the number of courses. Okay. And then teachers. Number of teachers are to be under the one department and number of students are to be under the one department. So these all are the childs. And then course. So what are the different courses are there? There is the theory courses and lab courses. So we have to be arranging all these elements into the tree structured form into the database. This is the one simple college database. Okay, this is the college database. College data we have to be stored into the database by using the hierarchical model in the tree structured format only. Okay, remember this. The next model is that network model. This is an extension of the hierarchical model. The network model is an extension of the hierarchical model. This model is same as the hierarchical model, but the main difference is that a record can have more than one parent. Remember this point. In that the hierarchical model, only one parent can have for the number of childs. Okay, na? That's the one child must and should can have, that's the only one parent. But here one child can have that's the more than one parent. That is the difference between the hierarchical model and the network model. So this network model is replaces the hierarchical tree with a graph. Means this the network model is a graph structured. Okay, na? So in this database model, data is more related as more relationships are established in this database model. Also, as the data is more related, hence accessing the data is also easier and fast. For example, why that's the data is easier to accessing and fast? Okay, why? Because of that in that's the hierarchical model must and should we have to be accessing that's the data. How we can to be accessing that's the data? First of all, we have to be searching that's the root node. Okay, that's the data is to be available in the root node or not. That is not to be available in the root node. So then we have to be searching the remaining child nodes. Okay, na? So every node we have to be searching. Okay, na? In that's the tree structure. In that's the net hierarchical model. There is the some more complex and that can take some time. There is the more time is to be required to accessing that's the data from the database in the hierarchical model. But in this the network model, it is easier and fast accessing of data from the database. The next one is this was the most widely used database model before relational model was introduced. Before introducing of the relational model, that's the network model was most widely used model. So yes, this is an example for that. What about this? So here A is the root node and B1, B2 are the child nodes and C1, C2, C3 are the another child nodes. So what is the parent for that's the C1 child? B1 only. What is the parents for the C2 child? That is the C2 can have that's the more than one parent. That is the B1 and B2. And then C3 is the one child. That's the C3 can have that's the only one parent only. So what about what we have to be observed in this diagram is that this the C2 child can have that's the more than one parent. That is the major difference will be occurred in that compared to that's the hierarchical model. In that's the hierarchical model, only one parent can have that's the child, not have the more than the one parent. Okay, this is then another example. Here college is the root node. That's the college can have the CSE department and library is there, and all students can to be accessing under this the CSE department and library. So here there's the CSE department and library are the parents of the student child. Okay, so that's why this the network model, that's the node can have that's the more than one child. Okay, and also it is accessing of data in this the network model is fast and easier. Got it? The next model is that entity relationship model. Entity relationship model, or simply ER model, is a high level data model diagram. It is also very easy for the developers to understand the system by just looking at the ER diagram. For example, I want to build the any database system. So must and should we developers who can to be develop the database system. So those developers to see this the ER diagram, they can to be easily to be understanding that's the database system. So just this the ER diagram as a visual tool to represent an ER model. Remember this. Just this the ER diagram is a visual tool to represent the ER model. And that is the ER model is based on the notion of real world entities and the relationships among them. What is an ER model? This the ER model can based on that's the real world entities and then relationship among those entities. What is an ER? That is an entity relationship model. So in the each and every ER model can consist of the entities and then their relationship between the entities. So that is about the point here. It is that entity relationship model is based on the notion of real world entities and relationships among them. Yes, this is the very important here. It is that there's the ER diagram has the following three components. One is for entities, second one is attributes, and the third one is relationships. The first one is entities. Entity is a real world thing. Okay, any real world object or any real world thing, that one is we have to be considered as a entity. So that it can be a person or place or even a concept. For example, our teachers are the one objects, okay, or one thing, and students, course, tables, okay, classroom, like that. These all are the entities. So real world object is nothing but an one entity. What is an attributes? Attributes is nothing but an property of an entity. Simply we have to be called that, okay, or an entity contains the real world property, okay, that is an attribute. Or simply you have to be say that the property of an entity is nothing but an attribute. What is an example for that? Here that's the teachers is the one entity. What are the properties of teachers? There is the teacher ID, salary, age, etc. So these all are the attributes of an entity teacher. Same in the student we have to be considered as a one entity. What are the attributes of the student? Student ID, student name, address, phone number, these all are the attributes of the student entity. So that's why this the attribute is in property of an entity. The next one is relationship. What is a relationship? Here that is the relationship tells how that's the two attributes are to be related. So these two attributes are to be there in that's the different entities. How those two attributes are to be related to each other. So for example, here there is a teacher works for the department. Yes, this is an examples for the ER diagram. Here that's the entities. These are the two entities and this is the relationship and attributes. Each and every entity can have that's the attributes, and we have to be relationship between the among two entities, that is in relationship. Okay, na? The relation between the two entities, that is nothing but an relationship. So for example, here it is that that's the teacher is the one entity and the department is the another entity. So what are the attributes of this teacher? Teacher name, teacher ID, mobile number, age, salary. And here is the department. In this the department, what are the attributes? Department ID and the department name. What's the relationship exist between these two entities? That is the works for relationship. That is the teacher works for department. So this is an example for the entity relationship model. The next type of data model is that relational model. Relational model is the most widely used model. In this model, the data is maintained in the form of two-dimensional table. So here in this the relational model, that's the data can to be maintained in the tabular form. Okay. So all the information is stored in the form of rows and columns. Actually, we are already know about the each and every table can contain the rows and columns. So our data we can to be stored, our information can to be stored in the form of rows and columns only in the relationship model. The basic structure of the relational model is tables. So how we can to be storing our information into the relational model in the tabular form? Remember this point. So the tables are also called relations in the relational model. For example, we have to be taken as an employee table. This is an example of the relational model. In this example can contains the 5 columns are to be there, and this the table or relation we have to be called, that's the entire table is a relation also, and each and every row we have to be called as an tuple, and each and every column we have to be called as an attributes. Okay na? So this is an two-dimensional table. In this the two-dimensional table can consist of number of rows and columns. We have the some employee data, so that employee data we can to be stored into the tabular form like this. This is an example of the relational model. Yeah, the next one is the object oriented model. The real world problems are more closely represented through the object oriented model only. So what is that meaning here? It is that the real world problems are more closely represented to the object oriented model. So here see this one. In this model, both the data and relationships are present in a single structure is known as a object. Simply you have to be remember that. How we can to be represent the data in the object oriented model in the form of objects. We have to be represent the data in the object oriented model in the form of objects. So means that's the object can to be described, that's the both data and then what's the relationship exist among those data that can to be described. It's mainly this the object oriented model can to be used to store audio, video, images, etc. in the database, which is not possible in the relational model. Very important this point. What is that is in the relational data model we have to be storing our information in the tabular form, but in that's the relational model it is not possible to store the audio files, video files and images, etc. But that's the possibility is to be there in this the object oriented model only. So in this the object oriented model we have to be described that's the data in the form of objects. This is an example for that's the object oriented model. So here this the employee is the one table and the department is the here there is the employee is the one object, here is the department is the another object. So what are the attributes of this object? That is the name, job title, phone number, salary, department ID, and methods or properties of this employee, that is the get, hide, change number. And here that's the department has the one object, that's the what are the attributes, that's the attributes are the department ID and the name are the attributes of the department. What are the methods? That is the change department is the one of the method we can to be used. So by this is the way we have to be represent the object in the object oriented model. Okay, so it is by using of this object oriented model it is possible to store our data in the form of objects, that is then audio files, video files and then images. It is possible to storing our data in the object oriented model only. That is not to be possible in the relational model. Simply you have to be remember that. Finally I have to be give the conclusion about these data models. There are the different types of data models we have. Nowadays we have mainly to be using the relational model. So in this the by using of the relational model we can to be represent the data in the tabular form only. We can storing our data into the tabular form only. In the first is to be introduced that the first data model is that hierarchical model. In that's the hierarchical model, that's the data can to be stored in the form of tree structured format. So that have must and should be can have, that's the one root node, that is the one parent and many children can have. And the next type of data model is that network model. In the network model, we have to be represent that's the data in the graph structured format only. But what's the major difference between the hierarchical model and the network model is that in that's the network model we have to be represent the data in the graph structured, and that's the child node can have that's the more than one parent. Okay, that is the major difference in between that's the network model and then hierarchical model. This is the most widely used model, that is the network model is the most widely used model before introducing about the relational model. And the next one is the ER model, that's the entity relationship model. ER model mainly using for that is an just to be a visual tool. Okay, so that's the developers can to be easily to be understanding that the system how that's the data base can to be created, how that's the database can to be developed. By using of this ER model, developer can easily to be identified. So we have to be represent that's the data in this the ER model in the form of entities and then relationship. There are the three how we can to be represent that's the data in the ER model in the form of ER diagrams. There are the three components are to be there in the ER diagram. Those are the entities, attributes, relationships. Okay, we using of these three components we can to be represent the ER diagram. And then the last and final one, that is the object oriented model, that's the data can to be represent is in the form of objects. Okay, mainly this the object oriented model can to be using to storing the video, audio and image format of data. Okay, thank you.